बिस्मिल्लाहिर्रहमानिर्रहीम।
शुरू अल्लाह के नाम से जो रहमान और रहीम है।
इक़रा बिस्मि रब्बिकल्लज़ी खलक़।
पढ़ो ए नबी अपने रब के नाम के साथ जिसने पैदा किया।
खलक़ल इंसान मिन अलक़।
जमे हुए खून के एक लोथड़े से इंसान की तख्लीक की।
इक़रा व रब्बुकल अकरम।
पढ़ो और तुम्हारा रब बड़ा करीम है।
अल्लज़ी अल्लम बिल क़लम।
जिसने कलम के जरिए से इल्म सिखाया।
अल्लमल इंसान मा लम यअलम।
इंसान को वो इल्म दिया जिसे वो न जानता था।
Assalamu alaikum to all of you. We start our class with the name of Allah, who is most beneficent and ever merciful. Students, in previous class we have started our second video session of our semester final. Today is second video in which we are going to study about the work that is included in week number 3. So it's a video about week number 3's work. In the previous video we have started chapter number 9, that's name was heating and cooling, in which we have discussed about temperature, heat, the process of heat gain and heat loss, and as well as we have discussed about the effect of heat gain and heat loss by different kinds of matter. And at last we have also discussed the application and the problem that caused due to the heat gain or heat loss, and or that caused due to the thermal contraction and expansion. A student, in the last video we have discussed that whenever a matter gains heat, it will expand, its temperature will increase, as well as its volume will also increase. As well as when a matter, either it is a solid, liquid or gas, loses heat, its temperature will drop down, its volume will decrease and it will contract. How much a matter contract or expand, it depends upon the kind of matter. The solid matter will always contract more as compared to liquid and gases. Why solid contract more? Because the particles in the solid are closer together, that's why contraction takes place in greater amount as compared to liquids and gases. Whereas in liquid and gases, contraction is lesser and expansion is greater. Why expansion of liquid is greater than solid? Because the particles in the liquid are far away from one another as compared to solid, but the expansion in gases is much more than solids and liquids, because the particles in the gases are much more far away from each other as compared to liquids and gases. It means gases के अंदर जो intercellular spaces हैं उनके particles में वो liquid और solid से ज़्यादा होती हैं, इसलिए gases में expansion ज़्यादा होगी and contraction will be less. अगर हम कंपेयर करें वाटर और गैस को, तो गैसेस में कॉन्ट्रैक्शन एक्सपेंशन ज्यादा होगी, कॉन्ट्रैक्शन कम होगी एज कंपेयर टू द लिक्विड. लिक्विड कॉन्ट्रैक्ट मोर एंड एक्सपेंड लेस एज कंपेयर टू गैस, बट सॉलिड एक्सपेंड्स very less as compared to liquid and gases and contract much more than liquids and gases. We can write in this form that expansion in solid is greater than liquid and expansion in liquid, contraction in solid is much more greater than liquid and contraction in gases is very less. When we compare the expansion among solid, liquid and gas, then expansion is gas is much more than liquid and expansion in liquid is greater than expansion in solid. तो सबसे कम एक्सपेंशन सॉलिड में है जबकि कॉन्ट्रैक्शन सबसे ज्यादा सॉलिड में है. क्यों? क्योंकि सॉलिड के पार्टिकल्स बहुत क्लोज होते हैं तो कॉन्ट्रैक्शन जल्दी होगी, एक्सपेंशन कम से कम होगी. इंटरसेलुलर स्पेसेस कम है तो एक्सपेंशन कम है, इंटरसेलुलर स्पेसेस ज्यादा है तो एक्सपेंशन ज्यादा है, कॉन्ट्रैक्शन कम हो जाती है. सो दिस इज अबाउट द लास्ट क्लास. नाउ आई एम गोइंग टू स्टार्ट टुडेज टॉपिक. इन टुडेज वीडियो क्लास वी विल डिस्कस the remaining topics of chapter number 9, topic 9.2 9.3. Yes, 9.3, in which we will discuss about methods of heat transfer, in which we will discuss 3 methods of heat transfer: conduction, convection and radiation. In last, we will discuss how we reduce the transfer of heat, how we can reduce the transfer of heat energy. Let's start with the methods of heat transfer. So first method of heat transfer we have conduction. Methods of heat transfer. The first method of heat transfer is conduction. What is conduction? It is the transfer of heat from one particle of matter to another particle from the lower region of the temperature to the higher region without the movement of medium. जब मीडियम की मूवमेंट ना हो और and particles will transfer the energy from one particles to another particle until the heat energy reach to the last particle of the matter. This is called conduction of heat. Let's take an example of a metal rod. If this metal rod is made up of different particles like this, when we provide heat to the very first particle, the first particle gains heat, starts vibration, then the heat will transfer to the next particle. In this way, the heat from first particle to the last particle will pass by the process of vibration. By vibration, the heat will be transferred from one particle to another particle. The particle number 1 will not move to the and take place to the particle place of particle number 10. Let's suppose this is the particle number 1. During conduction of heat, the particle number 1 do not replace the particle number 10, or particle number 10 is not replaced by the particle number 1, but the heat is transferred from first particle to the last particle by the vibration. So we can say that heat is transferring from the temperature of lower region. From the first particle, the temperature is lower. When the first particle gains energy, the temperature of remaining particle will lesser than the first particle. So step by step, the first particle transfer the heat to the second particle transfer the heat to the third particle. In this way, the heat from the lower region is transferring, the heat from the higher temperature region is transferring to the lower temperature region until the temperature of each and every particle will become same. If the temperature of this particle is 10 degree and the temperature of this particle is 0 degree, then the heat will continuously transferring to the last particle until the temperature of this particle reaches to 10 degrees centigrade. And during all this process, there is no movement of medium. The particles are just vibrating. So what will be the definition of conduction? The definition of conduction will be transfer of heat from the region of higher temperature towards the region of lower temperature without the movement of medium. Okay, there are so many objects which conducts heat. The object or the material that passes the heat from one particle to its last particle, these objects are called conductors. So conduction takes place in conductors. And what are conductors? Conductors are those materials and objects which allow heat to pass through them. Conductors have 3 types: good heat conductors, poor heat conductors or heat insulators, and the last one is non-heat conductors. What are good heat conductors? Good heat conductors are those materials and objects which allow almost all heat to pass through them. Almost all heat. Allow almost all heat to pass through them. For example, metals and solids. Whereas poor conductors and heat insulators are those materials or objects which allow little amount of heat. Little amount of heat to pass through them. And they are called heat insulator, thermal insulator or poor heat conductors. For example, non-metals, plastic, wood, etc. Non-heat conductors are those places which do not have any particle, like vacuum. Vacuum are those places which do not conduct heat. Non-heat conductors are vacuums. Vacuums are those places where there is no particle of solid, liquid and gases. So they are non-heat conductor. If there is a place where there is no liquid, solid or gas, this place do not conduct heat because there is no particle to transfer the heat from one particle to another particles. Here we have discussed about the good heat conductors, in which I have given you the example of metals. Metals are those objects which have shiny and lustrous surfaces and have free electrons. How does metal transfer the heat? Metals have free electrons that helps them to transfer heat energy quickly. That's why metals are very good heat conductors. Conductors are those materials and objects which easily transfer the heat. Now I am going to discuss about the application or the uses of conductors. We have discussed about good heat conductors and thermal insulators. Good heat conductors and heat insulators. And if we talk about our daily life uses, so we use different cooking pots and pans which are made up of metal, and these are the good heat conductors. If we talk about heat insulators, then in heat insulators we have handles of cooking pots and pans. Why we use good heat insulator in handles of cooking pots and pans? Because they do not get warm very fastly, so we can handle them easily. So these are few examples of uses of heat insulators and good heat conductors. How can we reduce the transfer of heat by the process of conduction? Conduction से हम किस तरह से heat transfer को रोक सकते हैं? All of you know that we have heat insulator, reducing the transfer of heat by conductors. How can we reduce the transfer of heat by using the conductors? All of you know that we have heat insulators. Heat insulators reduces the transfer of heat. So one way is the use of heat insulator. जब हम heat insulators को use करते हैं तो हम जो है use या transfer of heat को control कर सकते हैं. Let's suppose pan हमारे पास जो है वो easily गर्म हो जाएगा, hot हो जाएगा as compared to the handle. The handle reduces the heat conduction or the transfer of heat. The second one is use of, we can trap the air by using materials that can trap air. Air is a heat insulator. it does not conduct a large amount of heat. That's why if we use such kind of materials which can trap the heat, so conduction will be slow. What kind of material can trap the heat? It includes cotton, wool, fur. These are the materials that can trap the air, and due to the trap of air there will be the less transfer of heat. Okay. This is about the first method of heat transfer, in which we have discussed about the process of conduction, types of conductors, uses of conductors, and at last we have discussed about how can we reduce the process of heat transfer by using conductors. Now I am going to start the second method of heat transfer, that is convection. This method of heat transfer is different from the method of conduction. First of all, remember, this method of heat transfer takes place in fluids. This method of heat transfer takes place in fluids. What are fluids? Anything that can flow. Anything that can flow is called fluid. Let's suppose water can flow, so it will be fluid, it will be included in fluid, or air. Air and water are the fluids because they can flow. So convection takes place in water and air, whereas conduction takes place in solids. Conduction only takes place in solid, whereas convection takes place in water and air. Conduction also takes place in water and air, but in a very less amount as compared to solids. Let's start convection. What is convection? Convection is a method of heat transfer in which the heat is transferring from one particle to another particle by circular movement of the medium itself. एक ऐसा method heat transfer का जिसमें एक particle से दूसरे particle तक तो heat transfer हो रही है along with the movement of medium. Medium की movement के साथ साथ जब transfer हो heat, तो that will be called convection. What is the definition of convection? Convection is the transfer of heat from one particle to another particle by circulating movement of medium. When the medium is moving in circular motion and the heat is transferring from one particle to another particle, then this method of transfer of heat is called convection. Okay, this diagram is showing the process of convection that is taken place in liquid. When we provide the heat and boils the water that is present in the beaker, and after that when we add potassium permanganate crystals, then we can observe that when the potassium permanganate crystals are included or start dissolving in this water, this dye color shows that the water that has lower temperature, the water at the top that has lower temperature moves down, sinks down. As you can see, the arrows showing that the water from the top of the or the surface of the water sinks down. Why the water from the surface of the surface water sinks down? Because the surface water has lower temperature. The surface water surface has lower temperature. Due to the lower temperature, this water sinks down and gains heat from this heat source that is called Bunsen burner. The Bunsen burner provides the heat to the water particles that are present at the base of the beaker. When these particles gains energy, they moves upward. After gaining heat energy, they moves upward, they rises up, and as a result, the water particles which are present at the top, they sinks down because they are denser, whereas the particles after gaining heat, they become less denser as compared to the particles that are present at the top. So in this way, a circular stream is formed, and that circular stream is called convection current. This circular movement of water, this circular movement of the fluid will remain continue until the temperature of lower water surface or the upper or the top water surface becomes same. This is showing the transfer of heat from one particle to the last particle of the liquid by the circular movement of the medium, and this whole process is called convection, which is taken place in liquid. Another example of convection current or the process of convection that transfer the heat is also showing by this diagram, in which we have land as well as sea. All of you know that during hot day, the land first of all gains heat from the sun. When they gain heat, they start after gaining heat, they start to loses it, because if the surrounding temperature is lower than the temperature of the this land, then the land will start to loses the heat. When the land loses the heat, the air that is present over the land will becomes warmer. When the air gets warmer, the air will moves upward. Hot air, the warm air moves upward. When the warmer air moves upward, the place will be empty. As a result, the cold air that is moving from the sea, will replace the warmer air. जब समंदर की तरफ से ठंडी हवाएं आएंगी, तो जो गर्म हवा थी वो कहाँ गई? ऊपर, और गर्म हवा की जगह क्या आ गई? ठंडी हवा. The cool air that is flowing from the sea towards the land is called sea breeze. Sea breeze. What is sea breeze? The cool air that flows from sea towards land produces sea breezes. अगर यहाँ पर कन्वेक्शन नहीं होती, सर्कुलर मूवमेंट ऑफ वार्मर एयर ऊपर नहीं जाती, तो ये सी ब्रीज फॉर्म नहीं होती. सी ब्रीज कब फॉर्म हुई? जब कन्वेक्शन करंट बना. लैंड ने क्या किया? हीट गेन की. हीट गेन करने के बाद हीट लूज करना शुरू की. जब हीट लॉस हुई, तो वो हीट कहाँ चली गई? एयर में. एयर ने हीट गेन की, एयर वार्मर हो गई, एयर ऊपर चली गई. वार्मर एयर ऑलवेज मूव्स अपवर्ड. जब वार्मर एयर ऊपर चली गई, तो जो कूल एयर आ रही थी या कूलर एयर सी की तरफ से आ रही थी, वो कहाँ आ गई? लैंड की तरफ आ गई. और कौन सी ब्रीज बनी? वो सी ब्रीज बनी. सी ब्रीजेस आर प्रोड्यूसेस ड्यूरिंग डे टाइम, बट एट नाइट land breezes will produce. What are the land breeze? The land breeze are the breeze that produce at night when land loses heat quickly than sea. At night, the temperature of the land will increase. As a result, land start to lose its heat quickly as compared to the sea, and the breeze that will be formed is called land breeze. In this way, due to the convection current, two types of breezes will form at seaside. The first one is the sea breeze and the second one is the land breeze. Now I am going to discuss about the applications of convection current or the application of convection, where we are using convection in our daily life. Application of convection. Student, have you ever noticed why we placed the AC or why we fitted the AC at the top of the wall, why we made the ventilators at the top of the walls? It is just because as we have discussed that warmer air moves upward, whereas the cooler air sinks down. When we fitted the AC or we made the ventilators at the top of the wall, what will happen into the room? If the door is closed, then the warmer air will move upward. Garam hawa kahan ja rahi hai? Upar. If there is a ventilator, this air moves outside the ventilator and the cooler air comes into the room. In this way, the temperature of the room will become stable. Similarly, if we have AC that is fitted at the top of the wall, what will happen? The warmer air of the room will move upward and enter into the AC, whereas the cooler air from the AC comes into the room or sinks down into the room. This process will continue, this circular movement will continue until the temperature of the room will be set as you want. So this is the application of convection. So where we are using the convection, we are using the convection in ACs, in ventilators. Similarly, convection current is also applicable in refrigerators. What happened in the refrigerators? The warmer air moves upward and the cooler air moves downward, and as a result the temperature will set it. And the last one is in heaters. We always place the heater at the surface of the room. Why we place the heaters at the surface of the room? Because the cooler air sinks down and the warmer air moves upward. In this way, after some time, the temperature of the room will be set at warmer. Alright, so this is the application of convection. Now I am going to start the third method of heat transfer, that is radiation. Radiation. Radiation is a transfer of heat in the form of infrared rays when it travels, that can pass through vacuum. As we have already discussed that conduction takes place in solids, whereas convection takes place in liquids and gases. But there is a place, or there are some places where there is no solid, no liquid, or no gases. So how does heat transfer in these places? In these places, heat is transferring by a method that is called radiation. And what is radiation? Radiation is the transfer of heat in the form of infrared waves. What are infrared waves? Infrared waves are electromagnetic radiations that can easily travel through the vacuum, and vacuum is a place where there is no particle of any solid, liquid and gases. Okay, radiation always takes place through the vacuum. Vacuum में radiation होती है where there is no particle. All right, there are so many objects that can radiate heat. There are so many objects that can radiate heat as well as absorb heat, but there are some other materials also present in our surrounding that cannot radiate heat or nor it absorb heat, but they can reflect the heat. We have different types of surfaces. The first one is dull and black surfaces. Dull and black surfaces radiates and absorbs heat. First of all, dull and black surfaces absorbs heat. If the temperature of any dull or black surface is lesser than its surrounding, it will start to absorb heat. When the dull or black surface absorbs enough heat, it starts to radiate heat. It means it starts to emitting heat. It starts to releasing heat because the temperature of that dull and black surface is greater than that surrounding. For example, we have this diagram. Let's suppose the temperature of this container is lesser. If the temperature of this container is lesser than its surrounding, let's suppose the surrounding temperature is 100 degrees centigrade, what will happen? This dull and black surface will start to absorb the heat from its surrounding. When it absorbs enough heat, and if the temperature of this container will reach to 110 degrees centigrade, what will happen? In this situation, this dull and black container will start to radiate heat. अब क्या होगा? ये कंटेनर हीट को रेडिएट करना शुरू कर देगा, इमिट करना शुरू कर देगा, निकालना शुरू कर देगा. The heat will be emitted from the container if the temperature of the container is greater than the temperature of its surrounding. So this is called a dull or a black surface that radiates and absorbs heat greater than the shiny and silvery surfaces. If an object has shiny and silvery surfaces or dull or white surface, then that sort of objects reflect heat. They do not absorb heat as well as they do not radiate heat. Dull and black surfaces absorbs heat as well as radiate heat, whereas shiny silvery surfaces or dull or white surfaces, they do not absorb heat or neither they emit or radiate it, but they reflect the heat. All of you know that whenever a light strikes or on a mirror, it will reflect back. Similarly, when the heat energy enters into the reflecting into a shiny or silvery surfaces, it will not absorb, it will always reflected by these surfaces. I am going to show you the difference between dull and black surfaces and their ability to reflect heat or absorb heat. If we compare these two diagrams, the first one is the diagram of dull and black surface, whereas the second diagram is the diagram of white and shiny surface. If you look at this diagram, the dull and black surface, whereas the second diagram is showing the white and shiny container. Both have the same thermometer, but both are showing different temperature. The dull and black containers thermometer showing temperature 90 degrees centigrade, whereas the white and shiny surface container showing temperature 70 degrees centigrade. If we change or if we place both these container into under the sun, what will happen? Whose temperature will increase? Obviously the temperature of dull and black container will rises up because it absorbs more heat. It absorbs more heat as compared to the white and shiny surfaces that do not absorb heat. It always reflects the heat. That's why there is a difference between the temperature of both these thermometers of two different containers. The thermometer of dull and black surfaces showing the temperature 90 degrees centigrade, whereas the thermometer that is placed under the container that is dull and white is showing temperature 70 degrees centigrade. This is a temperature difference just because the ability of absorbing and radiating heat, whereas white and shiny surface, they do not absorb or radiate it, they just reflects the heat. That's why there is the temperature is lesser than the temperature of dull and black surface. What is the application of dull and black surfaces or white or shiny surfaces in our daily life, where we are using the dull and black surfaces and where we are using the shiny and silvery surfaces? If you look at the back of your refrigerator, there will be the black fins. Why they are black in color? Just because to radiate heat. If they radiate heat, the temperature of the fridge will become maintained, or the temperature of the fridge will remain at the cooling temperature. If the fin will be white in color, what will happen? The temperature of the refrigerator will rises up. Why it will rises up? Because the radiation, the process of radiating of heat is not taking place during this through these white fins. That's why black fins are used at the back of the refrigerator to maintain the temperature of the refrigerator. If we talk about the solar panels, the color of solar panels are black. Why solar panels are black in color? Because the solar panels absorbs the sun's heat. They absorb the sun's heat, and then after that, when they absorb enough amount of heat from the sun, they start to radiate it, and in the heat they are radiating, we are using in the form of light energy. All right. Similarly, the students use the white uniform. Why the students uses the white uniform? Because the white uniform they are wearing, they reflect the heat. They keeps them cooler. If they start using dark colors, or if they start using black color, what will happen? They will feel warmer, because that black color absorbs more heat as compared to the white. Similarly, if the fuel container will be colored black, अगर हम fuel container का black color कर दें, उसके container के surrounding में जो color है उसका अगर हम उसे black कर दें, what will happen? The container will explode. Why the container will explode? Because it gains enough amount of heat from the surrounding, and when they gain enough heat, they may be explode. That's why the fuel containers are usually used in dull and white, with dull and white surfaces. So this is all about today's class about chapter number 9, in which we have discussed about 3 methods of heat transfer: conduction, convection and radiation, and also discuss about how can we reduce the transfer of heat by different methods. We have discussed about how can we reduce the heat transfer by conduction, by using simply by using heat insulators. How can we reduce the transfer of heat by the process of radiation, by using dull and white surfaces. Okay, now I am going to give you the homework, video homework. You will do questions along with figure 9.39 at page number 211. And question along with figure 9.41 at page number 212. What will you do? You will do the question along with the figure 9.3 at page number 211, and also a question from figure 9.41 at page number 212. See the questions along with the diagrams and write down their answer on your own words by taking the help of this video. And in classwork, you will do review question number 7 to 10, think tank number 2, along with try it outs and think about it. Okay, what will you do? In your copy, you will do review question number 7, 8, 9 and 10 and think tank number 2 along with the try it outs and think about it. That will be provided in the content solution. Okay, we will start next chapter in today's video.